My duty to introduce the next speaker, which we can do very quickly. It's me. Oops, someone's ahead of me. I'm going to disappoint Andrew. I'm not going to talk about the single-step evaluation, and that's where we combine the DNA with the performance and the pedigree, because that's a work in progress. What I'm going to do is talk about some other aspects of us upgrading the genetic evaluation system that will produce some more immediate benefits. So the purpose of the SIL upgrade is really about three things. It's about removing variability, it's about increasing accuracy, and it's about faster turnaround. We can then also say, and adding in DNA. But let's have a look at this. At the moment, we've got a number of different evaluations that run, and each produce a different set of BVs because there's slightly different data going into them. So you've got a within-flock analysis that can occur for your flock. You can be a member of an across-flock group. Because you've been doing some DNA testing, you're part of the national genomic evaluation, and then you've agreed to be in SIL ACE, and so you can get some breeding values from those. All of those produce slightly different BVs, in some cases dramatically different BVs, because quite different data is going them in for the relatives of that animal. What we can't do at the moment with the current SIL system is do an analysis of all the data that's on SIL. And what we want to do is go to a system where we do one analysis of the whole of SIL. And what we'll do then is all the reports for either a within-flock report, and a cross-flock report about size, a national genomic evaluation, the same genetic run will be done for those. And here I'm talking about the existing way of doing a genomic evaluation. That's where we estimate the EBVs separately to the BVs that come from the DNA, and they're blended. The ultimate step is the next thing in the progression here, and that's where there's only one evaluation and the DNA and the performance and the pedigree data all go together. I'm not talking about that today, even though Andrew was desperate for me to talk to you about progress there. We are making progress. We've got people who are overseas at the moment talking with some of the leading lights in the world about that. I'm interested that Dan says they've got single step working in some of their analyses. We need to be putting more effort into that too to get that going. So, where do we go on this one? This development, or major development of the SIL system, has three components. It's about the evaluation system, it's about the genotype database, which was alluded to and described parts of it in the talk that Andrew just gave, and it's also about the core engine replacement. So that core there's two components. We can add in the DNA, but we also at the moment want to say, what can we do to the system to just get that core evaluation system going faster with the existing method we've got. And so I'm going to talk about mainly the first bit here, this upgrade. And you have to be careful with us people who work with the SIL system often. We talk about GE all the time. GE doesn't stand for genetic engineering. It stands for either genetic engine, which we know when we mean that, or it stands for genetic evaluation, and we know when we mean that. So if I get guilty of saying GE and you're not sure, I'll owe you a beer. So the key objectives in this part of the project was to say, we've got a problem at the moment. SIL ACE will not run for that large group of flocks. It's not the whole of SIL, but for the large group of flocks for some traits. We can't get all of the predicted traits in, so we're not adding via scan or CT data when we estimate meat yield with the SIL ACE data set, and we have some problems that we can't use all of the predictors that are available for fecal egg counts when we do the wormfect run. So SIL ACE is different in that regard to the evaluations that are done on smaller data sets. It takes some time to do this. I'll give you some times in a moment, but typically, if there's a week in which SIL is running, the computers are working for most of that week to do the analysis. And that's to do with the software we're using, which had its advantages when we introduced it, which was to bring in the accuracies, which you now can see for your breeding values and your indexes. But those accuracies came at a cost with the particular software we implemented them with. And at the time, that was the best way to go, but we now need to be getting a higher level of performance from the evaluation in terms of speed. Once we get that speed up and solve the problem of running that full data set, we need to scale it up so we can get that big data set of the whole of SIL through, so we can phase out on-demand evaluations for smaller data sets. Now, the advantage of this is that you won't be saying the breeding values, I need to make adjustments for outside size. All size will be in the analysis the whole time. If we use the genetic groups effect, which is another part of the development that Dan talked about, we can make adjustments for screened-in animals and for animals that truly are outside SIL that have come in and have been used because they're from a breeder outside SIL, but we can make the right adjustments for them. We want all of that in one evaluation. If you get a within-flock report and a cross-flock report or some national report, it's the same set of BVs if the evaluation was done at the same time. And I've just got ahead of myself. I talked about that adjustment for the outside size, screened-in animals, and also the crossbreeding. So there's a concern about that. You must remember that when you remove breed effects, the breed effects are part of an animal's genetic makeup. So but we want to try and tease out that heterosis or hybrid vigour and make sure that the genetic effects are being estimated in the right way and reported in the right way for users. And what we've got to do now is we've previously had a policy of saying connectedness is about an issue about which flocks should be in an analysis, and if they're not connected, we'll exclude their BVs, to having a system where we report back the information using connectedness as a criteria for reporting. And I've always been a great fan of the Australian system, of these Australian sheep BVs and these flock BVs, because it's a simple distinction. They've come from the same analysis, but the flock ones, which you can use reliably in flock, you can't reliably compare them across flock. They've got a slightly lower accuracy and the flock may not be connected for a trait. But if it says Australian sheep BV next to it, the breeders and farmers in Australia using those figures know that they can be compared with animals from another breeding flock. We could have a similar system here. So if we look at the performance of some new bits of software we've been testing, I'm just simply called these current software and new software. Here's what we've got when we've looked at Coopworth analyses. We've run the Coopworth data sets through both analyses, and you can see here for reproduction, for growth, for adult growth, and for meat traits, there's a very high correlation between the breeding values with the old software and the new software. This is the thing we had to check very early on because we want to know how much they might change. And the answer is the theory is exactly the same behind these different bits of software. It's been coded by different programmers. But because the theory is so similar, they've both got it right. It's a very high correlation. The small differences and the deviations from those correlations not being 1 or 100% the same relates to the fact that there's subtly different ways of how they handle data in matrices and how they solve equations. But the answer is they're very highly related. As well, the accuracies estimated by the two methods, very similar estimates came from them. There was a tendency for the new software to estimate slightly higher levels of accuracy, which again relates to the theory in which they were used. In this particular case, the current software we use has probably the best theory, but it comes at a huge penalty into the time it takes for the genetic evaluations to run. The fact that the new evaluations aren't based on quite such sound theory, but the answers are very highly related to our existing ones, is good. We can go with the faster software and get results that rank animals in a similar way for the accuracy of their breeding values. If we then look at the Texel analysis, it got even better. So I'm not quite sure what the difference between the Texels and the Coopworths is. Probably data quality. I think I hear a Texel breeder muttering. But you can see here that there's a very high correlation. The same set of data through two different systems, and you've got a very high relationship between the two. So these new bits of software, which I'll show you in a moment, are a lot faster. We have great confidence that they will produce the same BVs with almost identical accuracies. And I'm just going to look at what these values here mean. If you look at that 0.999, that's almost 1 for the live weight accuracy, for live weight 8 and carcass weight. And then there was a poorer one down at 0.973 for lean yield. So let's look at what that means in terms of a visual depiction of the data. You can see here for carcass weight, there's a very high relationship. If an animal has a high BV with the existing software, it has almost identical BV on the new software. There's very little variation about this line. For that 0.973 figure that we had for the lean yield, it's not such a good relationship. It's still a very, very strong relationship, but there are some animals which will re-rank a bit. And I'd sort of expect that for lean yield. Lean yield is a trait where we're adjusting the ultrasound measures and the CT measures for the animal's weight, and quite how those adjustments occur. You're starting to chip away at something that's a bit less variable. One of the biggest variations in lean weight is simply carcass weight. Once you convert it, so it's a lean yield, by taking the carcass weight difference out, the prediction is harder to do. So you can see here we're getting a strong relationship, but some animals are going to re-rank a bit with the new software. So the summary here, we've got near identical BVs for some traits, very, very close for others, and the accuracies that we found are very, very similar, if a slightly higher value for the new software. And the big conclusion is we get similar results. If we now look at the analysis times, these are the three data sets we've looked at this on. We looked at this Texel data set, we've looked at the Coopworth data set, and we looked at SIL ACE. And we've gone for the genetic evaluation module, which was the hardest one for us to run, the one that first showed the signs that things weren't working when it came to the number of traits we were using to predict breeding values, the number of breeding values we were estimating, and the volume of data that was going into them. So you can see here we've got just under 500,000 animals in the analysis for the Texels, about 1.5 million for the Coopworths, and SIL ACE was up at about the 4.5 million. The existing software for this meat lean analysis or module would take 11 hours to run for the Texels, 13 hours for the Coopworths, and we had to actually take some of the predictors out. So we don't have the Vioscan, we don't have the CT, but it was still taking 45 hours for two sub-modules which we created to run. So it was taking 90 hours to achieve the same BVs or generate the same BVs. This is where the problems were occurring. It's just taking so long to do it. Our experts, when BLG was being formed, said, look, there's better software than you've got available there. We think we can get this running at a fraction of the time. And I went, oh yeah, they'll be talking about, half the speed, quarter the speed, that sort of thing. Well, this is what happened. Massive change. We haven't got data on the Texel data set there, but the Coopworth data set went from 13 hours to half an hour, 26 times faster. And we got an even better performance gain. We got SIL ACE to run with all the predictors in, this massive data set, only in 1 hour 20. So our objective of being able to run the full analysis for SIL ACE through the computers in a week is absolutely on the cards. Now, while the computer's doing this analysis of meat lean, it's not doing analysis of the other traits. So we have to work out the optimum configuration of how many computers we have and how we schedule them. But we believe it's really on the cards to be able to deliver a weekly analysis that's done once a week of all the data on SIL. And so you just put your data in and you know that there will be analysis results released on a certain time of the week each week. So, summary of differences there. New software. It handles the largest of our current evaluations, SIL ACE, which the current software won't. It handles the full module for meat lean, which our current analysis won't. And it's much, much faster, absolutely simple. So we're going to be working with bigger data sets, more complex models, and much faster in future. So the key objectives we had up before, if I look at what I've talked about here, I've talked about these first two. I've talked about solving the problem with the current evaluations and about improving the speed. Our next step is to expand that out to the full SIL evaluation for this larger data set done quickly. We've got people working at the moment in the Ag Research Group down at Invermay on adjusting for crossbreeding and screened animals and outside size, and that's using this groups analysis that Dan talked about. And we've also beginning work on how we develop and implement enhanced tools to make connectedness part of reporting rather than whether or not you should be in the evaluation. So we might have a two-tier BV structure. So when will we get this super GE system? I've just told you we can do it, and it isn't there at the moment. And Graham said, this slide is missing from your talk. So we aim to have this by January 2016, and I checked with the people who are developing it before I wrote that. And they say that's feasible. For all traits, with groups fitted in the model, so that accounts for the outside size, the screening, and the crossbreeding. That's what our aim is, to deliver on those three augmented or enhancements to our evaluation module. And as a consequence of that, and this does affect you, we will progressively phase out the on-demand, smaller data set analyses that you currently have. So we'll maintain but not update existing hardware and software that we use for the analysis system. And as the computers go out of warranty, we will not replace them. We'll be looking at this new super system. And when we look at future developments like new traits or data audit tools or quality assessments, they'll be integrated into the new system. They will not be put into the old system as well. So how will you be affected by this? This is the most significant one. I've changed things. It's great. I've just told you they've changed. What's that change going to mean? The BVs will change. There's going to be a new larger data set. There'll be better models fitted to the data, and we'll be using different software. The biggest changes are to do those first ones. And that's exactly what we face at the moment when we're explaining why BVs from one analysis are different to another. It's because it's a different data set. Also, better fitting the data, so we'll be taking out some of those effects that a number of you are concerned about when it comes to things like crossbreeding, the screened-in animals having a bias. The key thing is we'll be making best use of the available data. So thank you. I did manage to detect there was an error in the timetable. Dan had an hour. The next talk was 45 minutes. The one was after that was a half an hour. This one's only 15 minutes. So I managed to remove some of my slides while I was sitting just down here before once I figured out that error. Any questions, please?
Mark, I see when you come down to this run in the future of weekly run, some breeder will get a printout this week and someone will get one next week, probably for the same sheep, and it will have a different thing, index. Now, the dairy people have an animal evaluation stamp with a date on it. And I think that's what you'll need to look at. Otherwise, it's going to confuse a lot of people when people are got figures on the same sheep and they've got different figures coming out.
You generally don't see the analysis done as frequently for it to be that thing. So you're cautioning against thinking that releasing things weekly will reduce confusion. It could introduce a new type of confusion. Thank you. Yes?
Time can be quite tight, especially approaching mating, sort of things like live weight 8 and eye muscle scanning coming in. If the SIL data is, say, runs its analysis on a Tuesday and we scan our ram hoggets on the Tuesday and enter our data that night or just after the SIL's done it, can we not get an analysis done including our data until the following Tuesday?
Our expectation is at the moment is we can reliably deliver an analysis every week. That gives us the ability that if one part of the analysis fails, we can still redo it and meet that weekly objective. While it would be possible to do them faster and on demand, everyone would want them on demand at a slightly different time within that week. So a limitation to our current system is the loss of the immediacy you get currently, where you can get your data to your bureau at 11 a.m. and the results can be in your inbox at 1 p.m. for a within-flock analysis. So does that create some management problems in terms of stud management and stock movement between measurement and culling selection decisions? Your feedback is welcome, and I accept that by phone, email, whatever. But it's a very good point, Robert. Thank you. Question here from Claire Callow.
You've commented on the speeding up of the analysis. Currently, with some of the reports, the actual time taken to feed those BVs back into the database and report can be time consuming. Is that going to improve with the new system?
It's not only about getting data onto our database, performance and pedigree. That data then has to be exported to the genetic engine, and once the breeding values are estimated, they have to be re-imported to the genetic engine. I'm going to give a very good steer here to either John Davies or his Andrew Cook, who work with the system, to comment on that.
And Claire, I had exactly the same question in my mind when Mark put those numbers up there, because they are only the numbers for the actual GE run. And we know that for SIL GE, exporting the data to the GE, pulling all the pieces of pedigree data together, actually takes longer than, well, not longer than the 2 lots of 45 hours, but it will take many times longer than the hour 20 minutes. We have a set of plans with the new SIL database working closely with the genetic engine developers to actually mitigate that and improve those times, both in terms of exporting the data and loading the data. But yes, there will still be some turnaround times there.
And you'll also have a problem with reporting, because everybody will have their reports all stacked up, ready to run on the Wednesday morning if this
That's a very good point,
weekly
Claire.
runs Tuesday night.
Yep.
And then we'll be able to have the rest of the week off, you see.
Yeah, I mean, this is one of the reasons we have these meetings, to get your feedback, and Claire, running a bureau, immediately sees that challenge there of her inbox exploding in size on a Wednesday morning or whatever when people want their reports. In terms of the data exported to the genetic engine, we don't see that as a big problem, because you export data to the genetic engine and thereafter you only export new data or changed data. So the database has to have a way of recording what's changed, and you don't bother exporting to the genetic engine data that hasn't changed. You're effectively updating the data that's sitting there at the analysis computer. But in terms of every analysis you do, potentially all the BVs have to be loaded back. So you're quite right, Claire, you identify that as being the loading of the BVs back from the database, and also that bottleneck of potential reporting will need to be addressed in the design. Thank you.